I'm Matt Summers. I'm operations manager for West Biofuels. We're a startup company working on biomass energy systems, converting waste materials into power and renewable fuels. What we've done so far out here is built out a plant that can produce gas from biomass, and we've also developed a plant that can take that gas and convert it into power.
Biomass materials is introduced into a bed of sand-like material that's heated. That heating of the biomass drives off gases, and those gases are what we use to either run an engine, or they can be reformed into what we call syngas, which is hydrogen CO, which can be run over a catalyst to make liquid fuels. One of the advantages of this type of a gasification process is it's very robust and is able to accept a broad range of biomass materials.
The concept is to help some of our ag industry, forestry partners take materials, byproducts from their industries that are already being generated, take and convert those into energy products.
The process we have here can produce ethanol, and we can reduce the CO2 emissions by 90% compared to the ethanol produced from corn fermentation to ethanol. The dual fluidized bed gasifier can be operated without any external energy, and in fact, in commercial applications, it would generate the gases, but it would also generate more power than it uses to perform the gasification. So it's a self-sustaining, self-contained process. The almond industry generates 800,000 tons a year of almond shells. That 800,000 tons a year can be converted into approximately 80 megawatts of power, or it can replace 12.5 billion cubic feet of natural gas. It can reduce greenhouse gases by 1 million tons of CO2 a year. And economically, for power production at wholesale, that 800,000 tons converted to 80 megawatts is worth about $60 million a year if they were to sell it into the grid at wholesale price. Using it internally, it's worth approximately $100 million a year and could make the almond industry completely self-sustained in terms of their energy utilization and their utilization of natural gas.
UC has been a great collaborative partner right from the outset of the founding of West Biofuels. We have collaborators out here at the site from University of California, San Diego, University of California, Davis, and UC Berkeley as well. And those are all part of our UC Discovery project.
By working with a private company, the problems we address come out of the problems the industry faces in trying to adapt or integrate this kind of technology into the California economy. It's allowed the university to work on critical issues both for the state and technical issues for new technologies.
The involvement of the UC has been critical. What UC brought to this was the ability to do sort of independent audit of the process, and now they've played a key role in helping us with innovation and process improvements. So this facility, the Woodland Biomass Research Center, and the collaboration with the University of California allows us to have the credibility to bring together a lot more people that are needed to make these projects happen in California.